So let's start looking at some examples and the sorts of questions that we can now answer with this theory. So, for instance, imagine an object were thrown upward with an initial velocity of 10 meters per second from ground level. Then the equation of motion would be 0. That's the initial height because of ground level. That means the height is 0. That's the most natural choice to pick for what we'll call the initial height. It is thrown upward with an initial speed of 10 meters per second, so v naught, the coefficient here is 10. That corresponds to this here. And this is always, when we're dealing with gravity under constant acceleration, equal to negative 4.9. So we now have the equation of motion. Let's see, well, one thing that we could figure out, given this, is how high the object is after 1 second. So we plug in 1, we calculate, and it comes out 5.1. What else can we ask and what can we do with this? So one thing that we can do is ask when will it return to the ground? And that corresponds to just setting it equal to 0, right? That would be where the height is equal to 0. And so by setting it equal to 0, using the fact that this is the height function, we can factor the t out of it, get two solutions. One is that t is equal to 0, but we already knew it's at ground level when time is equal to 0. That's when we threw it up from the ground. So that's not the interesting answer here. The interesting answer comes from the other factor, which when we solve is about 2.04. So that's the moment when it returns back to the ground. We could also ask another question like, what is the maximum height that the object reaches? Since this is a quadratic formula, then the maximum of that is the vertex of the parabola. And you might recall from high school that the vertex has a formula, negative b over 2a. So in this case, b is equal to positive 10, a is equal to negative 4.9, and we get the time coordinate of the vertex, right? This is just what you would plug in order to figure out the height at that time. But this is the time at which it reaches its maximum height. If we plug that in, we then find what the maximum height actually was, right? What is the time, or what is the height at that time? And we get 5.01. So those are problems that you can solve with this theory.